Okay, so welcome to the first class of our Safety 1051 Tools and Workplace Techniques, Venture College, September 2023. There we go. So how's that for an opening? All right, so in right now, you should see my mouse kind of moving, waving back and forth in the main class portal. If you don't, let me know. So this is just a quick recap of our navigation ways. Now, this is what you will be seeing when you log in to FOL, and if you select our class, the one that we're teaching right now, we're participating in, Safety 1051, 0, 1, 2, 3, 4, 5, 6. These are the sections, and that's 23, the year 2023 fall term. Okay, now this will be changing because that's where the announcements are going to be. Over here, here is my well, here's my information. If you need to contact me, here's my email. All right, now these are the announcements. Those are going to keep changing. This is a lecture for sections 1, 3, and 5. And then an hour from now, I'm going to have the same thing for section 2, 4, and 6. I just wonder how my brain is going to handle repeating the same thing all over. But let's leave it up to me. All right. Here's the welcome thing here. Now, here is our YouTube playlist. That's where all the recorded sessions are going to live. It's going to be populating. If you click on that, I think I have already. Yeah. If you click on that, that's where you're going to end up in this YouTube playlist. And you can see there is already one entry I posted. This is about reading the voltages on analog meter. We're going to get to that. So here's about 16 minutes that I'm going to ask you to watch because you need to know how to read the analog multimeter. It is important that once you graduate our program and you leave Venture College, it is important that you know as much as you possibly can. So reading the analog multimeters is important. I just wouldn't be calling myself if I didn't teach you how to do that. Now, there are some, right now, what we have is a lot of digital multimeters, and they are being used for the most part. However, there are situations that you really want to use an analog meter, and now we will explain as we go along. But anyways, here is the YouTube playlist, and it is going to start populating. This is also where I'm going to post the preparation videos for the labs that we're going to do. And I'm going to ask you to watch those prep videos because well, we need to be prepped for the labs. And as we already know, we're having a system of biweekly lab attendance. How do you find that? Just a quick recap again. Once you log into our class portal, I'm going to leave those permanently. That YouTube list here is going to be left permanently on. And here's our sections. Here's a list of our sections. Find your name here. Find out what sections you belong to. And you see here, it doesn't want to go further down, but here is the little thing that you need to click. I actually sent email about that because people seem to overlook that kind of this thing. Click on that. You're going to get more announcements that are actually posted, and you're going to see our lab schedule. I'm going to try to zoom in here. So once you find out which section you belong to, that's the only thing you're interested in. Let's say section 2. When is your first lab? You just keep going down the table. Oh, here's a lab. Lab 1 is going to be Friday, September 22nd. All right. And so now there's a couple of those orange sections, orange things here. We're going to have to not figure out, but we're going to have to tackle this thing as we go along. This is the no school day, and this is also a no school day, October 5th and October 6th, and that's where the labs fall in here. So Now, these labs are going to be simple ones, so you'll be able to sometimes, if you finish early your lab, you can tackle the second lab, which is going to be very similar to the first lab. And if you can, for whatever reasons, you can join any other sections to make this up to tackle this lab. You can tag along any sections. Just let me know that you're coming. All right. And also we have the week 14th right here. See that little watermark? That is the open lab. You can also do this thing during the open lab. So the options are many. The best option is leave that open lab for kind of like an emergency situation. Don't plan on using that for whatever reason. It's just for emergency situations. Things happen sometimes, a family function or whatnot. You get sick. There's a snow day. So leave that for the emergency type of a thing. Um, and as I said, you can join any of those. The list is here. The dates are here, and the times are here. So whenever you can, to make those labs, to kind of do these labs, please join some other sections and we will take care of you. And if for any other reason you can't, I will spend some extra time with you to do that. But we'll do it. We will cross the bridge as we come to it. All right. Okay, so this is just a quick kind of a recap on from the orientation residue type of stuff. Now, where are we here? This is we're back to the our class portal. Now, here's the content tab. Also look at the content tab. I'm going to zoom out just a little bit. All right, so if you click on the content tab, you're going to see that's where you are here. Now, you can see the course plan here in the course outline, and you can see student items. Let's click on the course outline first. Course outline, you're going to see two documents. This is the course outline. It's more generic kind of a description. If you want to look at the rules and regulations that have to do with this course. But the second document right here, and you can download that. This is our course plan. And it basically looks like this here. After you download it, there's our information. I put as much info as I could here. So here are the labs that we will be doing, weeks, course content, labs all combined are 50%. And this is the weight of the whole course. So all labs combined are 50% of the whole course. Quizzes, both combined, are worth 10% of the whole course. Assignment is going to be worth 10%, and test one and test two, 15% each, and all comes up, if you add it, it all comes up to 100%. Midterm grading, Tuesday, December 19, and we already explained the bi-weekly labs. Detailed schedule is already posted. And in order to pass this course, I have to say it, all labs must be attended, performed, and evaluated with the average passing grade, which is 50%. You can have average grade of all the labs, 80%, and if you haven't done one lab, you're still not completing the course. You're going to get an F as a fail. You're going to fail the course. Okay? It's important. And here's in red, the average evaluation for tests, quizzes, and assignment combined must be passing grade, which is 50% minimum. Okay? I have to say that. Now, if you keep scrolling down, here is our roadmap for the course. This is week 2 right now, September 11, Monday to September 15. I just put the span of the whole week right here. So today is September 11, Monday, and we are going to look at the multimeters. All right. So today we're having an online session. We're going to get the first part of the multimeters, and tomorrow we're going to meet in person, and we're going to tackle the second part of the multimeters class, and that's going to be week 2 this week. As far as theory goes, that's it, multimeters. Now, let's take a quick look at the lab schedule here. Do I have that somewhere quickly? Yes, I do. you go to course, not course outline, right here, main class portal, if you click on that, who am I going to see? Let's see all the announcements here. Schedule. Okay, September 13th is going to be Wednesday, and the first lab that we're going to see is going to be section 3. We're going to perform lab 1. Bring the tools listed in the lab materials. And we'll take a look at what that is. All right, what else? September 14th, Thursday, I'm going to see section 5. And September 15th, Friday, I'm going to see section 1, and we're going to do lab 1. And next week is going to be the same thing with different sections, right? So that's how we read that stuff. Now, just as a reminder, please bring your padlock. What do we need? Some people already saw that, okay? Well, what do we need? We need a Class E hard hat. Pretty much all the hard hats that are being sold in the hardware stores, in our college bookstore, it is Class E. The Class E is listed under the brim of the hard hat, kind of imprinted in plastic, or there's a sticker that's on the inside of the hard hat, and it's going to mention that's Class E. Type 1 is fine. All right, and boots, safety boots. I'm not allowed to let you in without the safety boots. Green patch, orange patch, and we went over that. And you also have already those notes posted to see what you have to look for. And CSA approved safety glasses. So when you buy the glasses, it should say, but you know what? All this stuff that's being sold in the store that you walk in, so Home Depot and other hardware stores, the safety glasses will be. Now, you also have the safety glasses in the other kit that you have purchased already. Those glasses are fine. Right? And the padlock. The reason why we need the padlock is that we're not supposed to bring our school bags, jackets, and whatnot to the class, because the class is kind of full of people. We won't be the only ones who are there. This is almost a simulation of a construction site. You're going to hear noises from other trades. There's a plumbing section, there's a welding section, there's some other classes going to be in the huge room. So in the background, you will hear some noises. Plus, because there's so many people there could be a tripping hazard if everybody brings their stuff and just lays them all over the place. So bring the padlock, and I'll show you around the corner from our class, from that big lab room, there's a set of temporary lockers that we're supposed to put our stuff, like school bags, jackets, and whatnot. And we just show up with the tools and our PPE, personal protective equipment, and bring yourselves with your wonderful brains, all right, and able hands. So you use that temporary locker, put your padlock on, and when the lab is done, you remove the stuff from the locker and take the padlock with you. All right, so that's the mysterious padlock thing. All right, so might as well. We're 15 minutes into the class and we haven't started yet. That's okay. So today is the multimeters, right? Actually, no, not yet. Student items. If you click on that here, all right. And if you go, that's our main class portal, content, student items, that's where all the content lives. I'm just going to collapse all the folders here. So I just divided that thing into theory and labs. Some other professors in other courses might divide it differently. All right, so theory, there's already some stuff being posted. So week 1, tools list, go over that. Click on that and look at the tools list. Hard hat and foot protection, PPE, and eye protection. Click on that. You will have all the information that's there. Now, go through that. This is the most common reasons for accidents to happen in the workplace. Also go through that. It's pretty self-explanatory. I will ask you some of the questions on the test. And already here's week 2, first part, multimeters posted lecture notes. We will go according to that, and these are the notes for you to keep and study from. It is pretty much a printout from the PowerPoint presentation that I'll be using. And tomorrow, see, this thing is kind of not in blue, it's like in black. So that means starts September 12th. It's going to be open for you to download or view on September 12th, which is tomorrow at 2 p.m. This one is already open. Okay. And labs right here. This is labs. Here's the first lab. I'm going to click on that, and you can download that. Here's the tools list that we need to bring. Okay, so now we need to have wire strippers, needle nose pliers, basic screwdrivers. We need red Robertson, green Robertson, and Phillips #1 and 2. And you need side cutters. You need side cutters as well. This here duplex receptacle and the lot of wire, it's going to be provided in the lab. So you don't need to buy a duplex receptacle and bring a wire. This here and that here, we will give you to work with. And here is the pretty much step-by-step procedure of what we're going to be doing. All right. Okay, finally, multimeters. Let's go. Where do I have it? Right here. There's my PowerPoint, and let's start this lesson here. Now it's going to be, what is it, F5 to start the show. There we go. Now I'm just going to take a quick look at the chat lines. Nobody else asking any question. By the way, if you want to have a question, if you want to ask me, you can type it in the chat line. Hopefully I will see it. I'll be kind of periodically looking at this chat line window, or you can just pipe in with voice. You can just make sure you unmute your microphone before you start speaking, okay? All right, so here is the multimeters. I gathered some pictures, showing different types of multimeters. The multimeter that you have is not the only one that exists on the market. There are hundreds, if not thousands, different type of diagnostic devices, and some of them are called just regular plain old multimeters, and some of them bear different names depending on the function or functions that they are designed to perform. Like, for example, this is one of those that we're going to be using. This is a data tester. Okay, that's nothing to do with testing voltages or current, but it's also considered a multimeter or a circuit testing device. This meter we will be using in the second term. This semester we're not going to use that. When we get to the data infrastructures, and our course is called network cabling, we will be using this thing a lot to test our Ethernet links that we're going to produce. Right? Now here, this one here and this one here, these are so-called clamp-on meters, and we have some of those in our classroom that you can measure current, and I'll show you how to measure current with something that's called a clamp-on meter. Now this is also a clamp-on meter, but for kind of smaller wires and more precise readings. And the multimeter that you have looks kind of closer to this type of multimeter right here with leads and probes and maybe some other attachments. Now, different manufacturers and companies produce different multimeters. Some of them are more expensive than others, and there are reasons for that. You might want to research something that's called the accuracy and definition of the multimeters, right? Yeah, different multimeters. Now, let's just not jump ahead. We're going to go systematically and study some of the qualities or the content that has to do with the multimeters. Now, also, I just threw in something that looks like more complicated piece of equipment, and of course they cost accordingly. This thing here could actually cost something like $10,000, right? To perform a little bit more complicated, measurements. And when you perform work for clients or in the field, sometimes you will buy some of those if you get lots of contracts that require you to use that, or sometimes if you use just once in a while, you can rent those as well, right? And when you rent more complicated diagnostic equipment, quite often it comes with the telephone number for the technical support on how to use that, right? All right, let's go slide number 2. Can I do that? There we go. Let's start with the definition of what multimeter is. A multimeter is, and sometimes I'm going to read what's on the screen, and I'm going to stop and explain some things. But just so I don't have something written, and while you're trying to read, I'm going to try to talk over you reading it, so you will not hear what I'm saying, and you will not be able to read. So that's my style of teaching. Basically, that's what it is, okay? So a multimeter is a device used to measure voltage, resistance, and current in electronic and electrical equipment. Using certain multimeter models, you can test to be sure that the components such as diodes, capacitors, and transistors function properly. So aside from just being able to test for the voltage and current and resistance, you can, some of the multimeters have other functions, and most of them do. Like, diode tester, for example, it's a pretty common thing. Capacitor tester, well, some of them do have that. You can actually stick in a capacitor, and he's going to tell you what the capacitance of the capacitor is. And some of them have attachments or built-in sockets that you can actually plug in a transistor, and it's going to show you the HFE, which is basically the amplification factor of the transistor. So as you go along, you'll learn more stuff, and you'll be able to use more features of multimeters that you have. You can also troubleshoot your circuit to see where the current is failing and pinpoint the problem spots. Troubleshooting is a science and art on its own. Right. So don't get intimidated when you hear the word troubleshooting. Well, as you go along, you'll be presented with different techniques and different approach. When it comes to troubleshooting, basic questions I'm going to give you. Well, the basic question that you have to ask yourself, if you have a piece of equipment that's kind of not functioning, the basic question to ask yourself is what is it that it's not doing? It's a loaded question, because in order for you to be able to tell what this thing is not doing, you should be able to figure out how this whole thing works and what it's supposed to be doing. And then out of that, what is it not doing? Right? And then you can approach can approach the troubleshooting activity with different ways as you see fit. All right. Multimeter is also used to test continuity between 2 points to verify if there are any breaks in the circuit line. So depending on the function that you select, the difference between a multimeter and a hammer is that multimeter can be used to perform more than one thing. Hammer, you just hit things with it, right? Or something like that. Advanced models are capable of graphing and printing waveforms and also storing some of the information that is being produced during the testing. All right, two basic styles of multimeters that you're going to see is going to be the analog, which looks like this. Here's a dial, here's a needle, and here's some scales. All right. In this one here, the value of the measured quantity is displayed by the deflecting of a mechanical pointer, the needle, against the analog scale. And depending on how you set this up, which scale you choose to read, and then you'll be able to figure out what the value of whatever you're measuring is. Now, aside from that, is the more common one right now that we're using is the digital multimeter. The value on this one is the value of the measured quantity, whatever it is displayed on a digital readout, mostly liquid crystal display. Now, I just decided that during the next slide, I showed you aside from LCD, there are different types of displays. We are not going to go over them. I'm going to encourage you to look through them, and I made these links. So once you download this thing in PDF form, you'll be able to click on those links to see some sort of a short explanation of what those different displays are. I strongly recommend that you go through some of that, because yes, you are going to use that information as you go along, because you are, in those type of technical field of technology that you are, right? And it's just, I put a little arrow here, click to see examples and explanations there, right? All right, okay, so I got two basic styles. We have the analog and the digital, but now we take a look at the digital meters and let's see what there are two different basic styles of the digital multimeters. First is a switched and auto range. What do we have here? This is what a switched scale multimeter looks like, and this is what a auto range multimeter looks like. Now, over here, I wonder if I can zoom in or not on this thing here. Yeah, I can. All right, when you look at the switched scale multimeter, what do you see here? You see different quantities. So over here, from here to about here, see there's a little line here and there's a little line. You can measure AC voltages, not from here to here. This one is a scale of up to 600 volts AC. 200 volts AC. And then there is amp meters, 200 micros, 200 milli. This is telling you the upper limit of what you're measuring. Somewhere along here, there should be a line distinguishing AC volts and DC amps, all right? Maybe it's missing, someone erased it. So in here, you have a range of current, measuring current. So you can measure, well, electrical current. And here are the ranges up to, well, up to, I think this is the DC amp meter, up to 200 microamps, up to 20 milliamps, up to 200 milliamps, up to 10 amps. So this is if you have current going in the circuit that is, let's say, 3 amps, 3 amperes, then you would not be able to measure that if you select the range, this range here, because this range can only measure current that is up to 200 milliamps. And if you have a 3 amperes or 3 amps going through this circuit, you would have to select the next bigger one, which would be up to 10 amps, and 3 amps fits within that range. All right. Now this one here is a battery tester, 9 volt, 1.5 volts. Is going to tell you if the battery is good and bad, and how it's actually testing, how the current you to, if you have this multimeter, just read the manual and read the explanation of how this particular meter approaches this type of measurement. Now over here, there's a continuity tester. We'll go through that later. Tomorrow, here's a diode tester, and now here is the resistance section. Now here, this resistance, if you select this range, if you dial this here, you're going to be able to measure the quantity or resistance up to 2 mega ohms. Mega means million, so up to 2 million ohms you can measure. Now, if you want to measure some smaller resistance, this thing is going to measure up to 20 kilo, 200 kilo, which is 200,000 ohms. Here is up to 20 kilo, which means up to 20 kilo ohms, and so on. So you decide, if you're in the resistance section, you decide for the most accurate measurement, you can decide which range to switch to. Here is DC voltages. Okay, so this one here, we measure up to 200 volts DC. This one here is going to measure up to 200 volts AC, which is alternate current. Okay, and so on here. So you not only you select the function, which is like within here, this is a voltmeter. Within here, over here, this is an amp meter. Over here is a continuity. So this is the multimeter can perform lots of different functions. Over here, it's an amp meter to measure resistance, right? And not only you switch the quantity that you want to measure, you actually are in control of which range to select for, well, 2 reasons. One, so you can measure things at all. And 2 is so you can measure things with the most accuracy. And we will cover that. We'll talk about that later. How to select the proper range for the most accurate measurement. Right? Now, the display over here would show you that you're measuring AC voltages, okay? And here's a 600, so you can measure up to 600 volts AC this way. That's what that's what this thing is selected. Now, I'm not sure what this auto means, because in different different multimeters there could be some other icons that are, well, that correspond to this particular model. So always read the manual, find out what everything is, find out as much as possible, so you can use the multimeter comfortably. Now, this is a switched range multimeter as opposed to auto range multimeter. See the difference in the dial here? Difference between this and that is that here you just have the quantities that you want to measure without breaking it into ranges. So if you know that you're measuring AC volts, you switch that just to that icon that shows AC voltage. And the multimeter is going to automatically select the best range for that, so you get the most accurate reading based on, it's going to say, I think you want that range for that. Now, if you see DC voltages, just click on that and it's going to automatically adjust itself to give you the most accurate reading. It's a thing of preference. Some people prefer to use the auto range. Some people prefer to use the switched range. Personally, I prefer the switched range because it's just like driving a automatic transmission car or standard transmission car. I want to be in control of what this thing does, and this gives me a little bit more control. Now, there's nothing wrong with using this auto range. Some people prefer that, and that's fine as well. I'm going to zoom out to the original. There we go. Now, let's see. Is that the next slide? Oh, okay. Well, this is basically what I just said here. Manual, switching, ranges. This is just a function selection. You can read that. And the keyword is for the most accurate reading, where we will expand that thing soon enough. All right. So I'm going to elaborate on that. Now, categories. Okay, you hear a lot in the within the technical jargon. You hear something like Cat 3, Cat 5, and so on, Cat 6. Probably when you hear that, it would be in the context of the data cable. Data Cat 5, data Cat 6, Cat 5e, Cat 6a, or whatnot. This is not. This has nothing to do with that. We are talking about the categories of a meter, measurement categories, and which meter to choose. And meters do have categories, right? So forget the cabling thing right now, as far as Cat 5e Ethernet cable. That has nothing to do with that. This is Cat 4 measurement. So you need to have a Cat 4 multimeter that fulfills the specifications of that. If you choose the wrong category, a lower category, and measure on a multimeter while measuring higher category quantity, well, such as voltage, it could have devastating consequences. Pretty much this whole thing can blow up in your hands and you can get hurt. So pay attention to this. Now, we are just listed Cat 2, Category 3, and Category 4 type of measurements that have to do with type of multimeters that we have to select. Now, we're going to start with Category 2, and I'll tell you why I did not mention Category 1. Because Category 1 is measuring things like resistances or continuity or measuring diodes or transistors, things that do not require you to measure any quantity that involves power. Measuring a resistor of a resistance, you are measuring something that is sitting there, not plugged into anything. It's passive. So we're just going to concentrate on things that are powered up that we're going to measure. Cat 2. Single phase receptacle connected loads. Single phase as opposed to three phase. I'm not going to expand on a single phase or three phase, or sometimes you get, well, just two phases connected to your household. Now, what does it say here? Appliances, portable tools, and other household similar loads. What is a load? Well, you got a power supply that's supplying the power, and you got something that you plug into it, and the thing that you plug in, that becomes a load to the power supply, right? So a refrigerator is a load to our household wiring. Okay? Well, the electrical panel would be considered as power supply. All right, let's keep going with this. Outlets and long branch circuits. All right, so let's just get rid of some confusion. Sometimes you're going to hear something like short circuit. Well, there's no such thing as long circuit. When it comes to short circuit, you can have short circuit or open circuit. Just going to bring up my little, can I do this? Yeah, I can. My mouse is getting funny. All right, so I'm just going to use a pencil here. If you have a power supply, DC power supply, this is always plus, the longer side is plus, the smaller side is minus. And if you have something like a resistor plugged into it, so this resistor is a load to the power supply, whatever the voltage is. Now, if you drop a kitchen knife across the bare copper conductors, you're going to connect these 2 points right here, which means that this circuit is shorted. It's connected unexpectedly or before the load. The load doesn't see the circuit, so the current is going to start going like crazy just through that short here. So there is no short or long. It's a short or, let me get my eraser a little bit bigger right here. You could have something that is an open circuit eraser. If you break the wire, you have an open circuit. Okay, so now this has nothing to do with what's being explained here. You can measure with this type of a meter outlets that are more than 10 meters or 30 feet from the Cat3 source. Cat3 source would be a electrical panel that is inside the house. Okay. Now, at more than 20 meters, 60 feet, or you can measure also if you're further than 20 meters or 60 feet from the Cat4 source, which is anything that's outside. You see here, here's a transformer, that's a Cat4 source. Outside, here is the meter. Here's the service that's connected to the house. It is outside of your house. As soon as it's outside, it automatically becomes Cat4. So that's when we have long branch and short branch terminology. Right? So this here, more than for the Cat2, you can measure things that are further than 30 feet from Cat3 source. So this outlet here will be considered you can measure that with the Cat2 meter. If it is further than 10 meters or 30 feet, that's considered a long branch. If it's closer physically to that, that becomes a short branch circuit. And then you have to up the meter. Okay. Now, let's look at Cat3. So Cat2, it would be those outlets here. What else do we have? Well, outlets, receptacles, for the most part, or lamp holders, things like that. Cat3, it could be three-phase distribution. If so, that would, either one or two phase or three-phase distribution panels. You'll be studying those, including single-phase commercial lighting, because they require much more power. So you need to have a meter that is able to handle that type of power if something goes wrong. Right. So what do we have here for Cat3? Okay. Over here, we just see electrical panels, distribution panel, or the transformers, fixed installation. That would be mostly somewhere close to the electrical room or the area where the power is provided, the service is provided. So what do we have here? Equipment in fixed installations such as switchgear and polyphasor motors. So you're talking industrial electrical work. Bus and feeder industrial plants, distribution panels, devices, lighting system in large buildings, appliance outlets, short connecting service with short connections, with short connections to service, which means they have to be close to the service that is provided here. Okay. Now, here is Cat4 source or measurement. You see, Cat4 outside, meter outside, Cat4, transformer, Cat5, sorry, Cat5, Cat4 outside. Right? Electricity meters right here, primary overcurrent protection equipment, outside service, entrance service drop from a pole building right here, run between meters and panels, so right here, and overhead line to detached building. So anything outside is Cat4. Buried cable is also Cat4 meter. Why do we need to have different categories? Well, different meters are built in a way that they can handle more or less power. And if something goes wrong within a small, I was going to use the term loosely, if the power is not huge enough that it can actually do you some serious physical damage, and they're talking an arc flash, which we'll study as well. Then if something goes wrong, maybe the printed circuit board on that meter is not designed to withstand certain type of high power sources, then it can let go. It can act as a short circuit, and then you have all the power that goes in there, so you can have an arc flash right in your hands. You can seriously get physically damaged. So that's why we have categories of the sources, which correspond to the categories of the meters that can handle or should be applied accordingly to the categories of the power sources. Now, let's see the next. How can you tell which, like that, your multimeter, the one that you have, right? I think it's this one here or maybe a similar one. There should be somewhere, the information should be somewhere there. Like, for example, here at the back, I just have that little zoom in. I just took a picture of that and I zoomed in. What does it say here? You can measure up to 600 volts of category if you're dealing with Cat3 sources, category 3 sources. Or you can measure up to 1000 volts if you are measuring category 2 source. Category 2 source up to 1000 volts. And here is the rules, sort of. And here is a category 3 source. So here is how you can read the specifications on your thing. All right. Types of meters. Meters can be very simple, such as these. Look at this. This is a auto range, very simple. This one here, I don't think you can you measure voltage on this? I think you can measure voltage. There's a little sign here. Da, 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 da. So it's auto range. Yeah, very simple. 1, 2, you can just have 2 and off. And then you have some building. Yeah, okay, so it's a simple thing. This is also a simple meter. That one also is a simple meter, clamp on meter. They could be very simple, but every little thing that you get that is looks like some kind of a smart device, always read the manual to get the full benefit of the first. Well, two reasons. Reason number one, you get the full benefit of the equipment that you're using. Two is so you don't do wrong things with it. Okay. And meters can be very complex to the point that training could be required. Some meters come with live tech support, as I just mentioned. Sometimes you're going to be doing, you will be requiring of measuring or performing some diagnostic tests on various different, on different pieces of equipment. And if you use the same meter all the time, you're going to learn how to use that. Of course, you're going to learn, but sometimes you're going to have some oddball situations that, like for example, you're going to have to measure the DSL line, and they're going to send you a DSL tester, and when that thing comes by mail or whatnot for you to rent to use it, you won't even know how to turn it on sometimes. So it might come with the 800 number to call to get you started. Right? Of course, you have to know your stuff. They're just going to tell you how to access certain types of measurements within that particular equipment. All right, now let's take a quick look at the meter leads. These are the leads. Here's the tip of the lead. Here's the probe. And here's the lead. And here's the plug. And here are the ports. Right? Usually we get black and red type of a lead. Red is usually connected to voltage, resistance, or amperage port, is considered a positive connection. Make sure you know where you plug things in. Black meter lead is always connected to the common port. Nice. It's covered. Considered a negative lead. Okay. Probes are the handles right here. And there's the tips. And these are the ports. Now, do I have... Okay, let me just click on these here, and here. Here is the digital display. We already talked about that. Over here, that little thing, that little handle here is a meter dial that you select. Functions on the panel indicator right here. What you want to measure. Switch here, you have just turned that piece of equipment into a voltmeter that can measure AC voltages and so on. Turn it here, you are in the ohm meter section, and this thing will behave in a different way. So here's the common port. You would just plug in the black lead. Now, depending on the quantity you want to measure on this particular meter, if you want to measure volts or ohms, or if you want to have a temperature meter or diode tester or a capacitor tester, that red goes here. And these are the two leads that you're going to use. If you're measuring amps, milliamps, and microamps, you would have this and that. So the black stays there, and the red, from here, it changes into here. That's where you plug it in. Now, this one here shows, can I zoom in just a bit? Oops. Here. This one will show that here, between these two ports, you can measure up to 400 milliamps. Because this doesn't show, this is an auto range meter. So here's an extra information. On this one here, you can measure the current of up to 400 milliamps. So milli is stand to the -3, which is 400 thousandths of a meter. So 1,000th of a meter, if you divide 1 meter by 1,000 and multiply it by 400, you're going to get 400 milliamps. Okay, if you measure if the current that goes through the circuit is bigger than that, it's just going to activate the fuse. You're just going to blow the fuse on that, and it won't let you do it anymore. So you're going to change the fuse. Now, if you want to have amps, then you use these two, and there's a bigger fuse there inside the multimeter. And this is the end of this first part of the multimeters. We're going to expand of some of that knowledge next time I see you, which is going to be tomorrow. And we're going to do that in person. All right. Now, I'm going to have to end this class right now because I have another class, which is the same for the other sections 2, 4, and 6. And the Zoom thing is going to take some time to process that. So thank you very much, guys, and I'll see you in person tomorrow. Where are we here? And I think I pressed that.